Well, let's have a look at two questions here, question 18 and question 19. So we've got function x is the square of x and g is square root of x squared minus, is that a minus? Yeah, there's a little dot, okay. So we want, we'll just go back, copy that, copy that. Oh, I lost my whiteboard. Oh, there it is. Okay. Let's go across to this one. Okay. We want the domain of the function of g. Now we put g into f. So that when you substitute g, the domain of g will give us a range. And then we substitute that into f so that the range of g goes into f, becomes the domain of f. Okay, so let's have a look at this function. So first of all, what is x squared minus 2x? So x squared minus 2x is a graph that cuts through the 0, 0, crosses at 2, turns at 1, substitute 1 in there. Okay. Now the g is restricted from negative infinity up to 0. So really, negative infinity up to 0, including, it's a square bracket. Okay, so including 0. All right. So the domain of g, which is from negative infinity to 0, substitutes into g. And with that domain, we get a range. And the range is from 0 to infinity. Okay, so that's the range of g. Now let's substitute this into, well, that's a square bracket. Let's substitute that. That becomes the domain of f. So the domain of f is then from 0 to infinity. Okay, let's substitute. Let's see what f is, a square root of x. So let's put square root of x. Now you substitute 0. We can use a 0, that's fine. And we can go all the way up to infinity, that's fine. When you substitute 0 into, that function, you get 0. And that includes, and you can't have infinity. That's the range. So the range of f, turns out to be the same as the domain, from 0 to infinity, 0 to infinity. So the x-axis you can see is from 0 to infinity. The y-axis is the range from 0 to infinity. Okay, so here's the domain of f. That's the range. Here's the domain of f, which is, we want the domain and range of f of g of x. Okay, now let's go back to not just the domain of f, but f of g of x. So we are permitted to use our original domain here. That's the domain of g, which is fine. We can use the whole thing. And then that gives us the range. That becomes the domain of f. And then that becomes the range. So we've got the domain of g is the domain of f of g of x. That's the original domain, negative infinity up to 0. And the range is from 0 to infinity. Okay. Question 19. Well, this looks complicated. We've got g being a particular domain, and it maps to R. Now, g of x, I'm going to look at the parent function of 1 over x. If you know the parent function of 1 over x, excuse my graph, it's going to look like this. And if we're going to move that to the right a, to the right by a, it moves across to this position. And then it's going to be moved up b. All right, so we're going to move that up b. I'm just going to now put a value b here, and then that would become the graph. All right. Now we want the domain, the range. Well, the range is all values except b. Oh, is that all? That's it? We didn't want the domain, we want the range, right? Okay. There it is. All values except b. They didn't ask us for the domain. Just checking. Oh, actually, yeah, no, it's not. It's not, because there's a restricted domain for G. So let's go back to the restricted domain. We're restricting our domain from negative A to positive A. Okay, so from negative A, including negative A, but not including A. All right, we can't have A, but we can have negative A. Negative A is over here. So that is here, okay, on our graph, up to, and then from A to 2A. Okay, so from A to 2A, that's another A. That's here. Okay, now we've got a restricted domain. Yes, we can. You can see from here, it's going to go all the way to negative infinity and up to this value here, which originally, the apparent function originally was negative 2a. So if you substitute negative 2a into the original function, you get our value of negative 2a. If you put that into our original function, our parent function is f. That's the blue graph. Because you could see this is 2a away. From this line, it's across 2a. And so if you move that, it's across 2a. It would have been negative 1 over 2a. And that is the value of this point here. And we can include that. Now we want this value. You substitute 1a because it's 1a in the original function. It got moved across to 2a. But if you substitute 1a, you will get 1 over a. That was this value here. It's been moved across and then up. So we can include that, which is 1 over a, all the way up to infinity. Okay, that's better. That's more complicated than I thought it was. We're looking at, oh, I forgot to add b, plus b, because we moved it up. Our range plus b. So b plus 1 over a and b minus 1 over 2a. The square brackets. All right, we've got to have that square bracket. All right. That was a little bit more difficult than I thought it was.